Hello and welcome. I'm Bill Wake. We're here working on a program to compare tunes for similarity. Lately, we've been working on clustering so that two tunes that are very similar end up close together in our list. And for now, we want to switch over from some more algorithmic cleanup to the idea of selecting clusters and how do we choose which things we want to look at. All right. Let's see. I did a couple thjust overnight. One is I changed the dimensions of the cluster so the arms are not all the same length. And the second is I just shortened our line a couple of pixels just so we don't overlap it. I know we're going to really come back and address the total look of it later, but I don't know, it was just too annoying. But that's just subtracting 3 somewhere. I should put it in a constant. So, all right, but let's go back. What I do want to do though is we want to give the ability to select any of these nodes. So right now we show them all selected. I think maybe initially we'll just show the topmost cluster, and hopefully that'll give the idea that maybe you could click one of these other diamonds and see something. The interaction I want is if you click something, any node, well, that node and its children or its descendants, like if I click here, this node, and this node, all those should light up. I'm sorry, all those should have the diamond selected with a inset diamond like this, and ideally bold its elements on the right. And anything not in that tree, like siblings and so on, cousins of various sorts, ancestors, those should turn into an empty diamond. All right, and I'm kind of trying to combine a little bit like a combination of a checkbox and an option selection. So you know how you have radio buttons with round circles and an inset dot. And a checkbox has a square with a check mark in it. This is kind of a blend of both. And I recall there was, what was it? Tog on software, Tog on something. Bruce Tognazini had a book about design and software and miscellaneous things, and designed another checkbox that was kind of like this. And it was kind of like an option thing, but you couldn't deselect the last one. You could select one or more. It was a one or more selector, which is useful too, but we're going to try this for now. And so thinking about what we need, I think what that involves is we've got to know the root, because if I click this thing, it probably we can make it know its cluster. And from that cluster or connector, it knows the ones beneath it recursively. So that's fine. We can just tell this and all its children to set themselves. But we also need to tell the root to clear itself and any of its descendants except the ones that are descendants of this. Okay, so I don't know. It feels a little complicated. We might be able to combine that into one clause. I mean, it's like go to the root, and until you match the cluster, clear things. Nah, I don't know. We'll see. All right, but I think you need those two aspects. You need to be able to say what's in this connector and its descendants, and you need to be able to say, I got to let that root know that everything should clear. Now, let's see. The other thing is those elements selected. Yeah, I mean, yeah, conceptually you could do that as well. Although I don't know if I'd want to per se. What can happen is I don't know. It's all probably fast enough, but if you clear first and then reset, then you got this chance of a blink that doesn't really need to be there. And if our lines are going to be bolded, you know, they would flash, they're bold to start with, they would flash off and then flash back to bold. So you'd see this jitter. But, you know, that may be that's certainly simpler and easier to get right. And maybe the jitter is not going to happen. Maybe things are fast enough. All right. So, well, I do limited TDD on the graphic stuff, but I think maybe the easiest thing to set is if somebody clicks on a node, I can definitely get the list of elements and of its descendants, and then trigger those becoming bold. I think that'll be a good, easy start. The more complicated on and off stuff, yeah, I don't know. All right, so let's assume we're going to do that. So the normal thing we'll have to do is define some entity that we update and that our view uses to catch how to say this. I mean, it's a user interface update because it's kind of reacting to the change in this object. And so like where we draw these names, okay, like here we wanted to say bold. Well, we want to bold it if that element is one that should be. And elements, let's see what they have. Well, they have the, well, is it right? Is element, let's go look at cluster elements. Okay, so if we're a cluster of these, oh, he doesn't have identifiers. Okay, well, let's see what we can do. Well, so one thing I can do is if something is bolded or wants to be bolded, let's see. I don't know, is that bold? Bold is active. Okay. Yeah, so we'll define that. And then I think we need this notion of what are the selected elements? Well, I think this is where our elements are. This int on line 8, I don't know, maybe it's time to make this class have children. We know it has to be hashable. I think it may have to be identifiable. Okay, but this should be cluster of E. And let's see, somebody should be complaining. Self.cluster equals C5. Cluster.element, well, E is hashable. That seems okay. C5 should be a cluster of int because C4 is, because C3 is, because their elements here are ints. Okay, let's see what else we got. Conflicting arguments to parameter content, whole versus content, whole versus whole versus whole. Okay. Well, maybe that's not a good move. We're not trying to get beyond the ints right now, but maybe cluster event to type cluster of E. Okay, cluster event is right, but how do we know what E is? Self.cluster. What if I do this? Is it not hashable? Maybe coming from inside is not the best thing. All right, I'm not going to worry about the E bit then. We will have to do something about that later. All right. I'll just keep it close for now. All right, so let's have elements, and I think we're going to say they are state. Well, let's call it selection, selected elements. Is an array of int. Okay, and it initializes to empty. Okay. Now, I want to say this is a constructor, so I'm going to do a bit of deferred work, which lets me update fields. I don't think I can do it without this. So if I said cluster equals 5, and then I said elements, selected elements equals self.cluster.elements. Okay, I think it'll complain. No? Okay, good. All right, so now I'm selecting off the list of selected things. And then my drawing, I said I wanted this to be bold. And is active is if selected elements dot contains element. Okay, so if my selection contains that, then it should be bolded. And I don't think that's too bad. So I'm guessing everything, I believe everything should be bolded. Okay, and nothing is. What does that tell me? Okay. Sorry, let's see. So I can't tell if this is true, so let's add it to our notation here, just to get a little feedback. Instance method. Will inherit from NS object. Okay, let's try that. I'm saying this because I selected, yeah, all right. Let's see if I've done things the way I think. So I've got this state. It's the list of elements. And then I store that from the current selected cluster. Now, when I draw these things, I want to know if selected elements contains element. Okay. Well, let's... I don't know if I can print in here. I think I can. So I'm expecting 1, 2, 7, 8, 10, 11 to all be in that list. And they are not. Self.cluster. How about print C1.elements? Let's break here as well. Okay. Step out. Okay. Okay. C1 has those two elements. Okay. You know, I think I'm messing myself up because I don't know if the initialization, maybe it's more of a one-shot. Use before initialized. Right. Let's do it this way. And just emphasize this. I don't care about that anymore. Self.6 elements is used before being initialized. I don't think that should change anything. Okay, let me try this. I don't think I should. I mean, because I'm going to have to be able to reset it and stuff like that. So it seems like I should just be able to treat it like a, I mean, state says this really is a variable. It's okay, even though it's in a struct and all that, because the view mechanism uses that. Let me try this in the defer. Well, I'm willing to try. cluster used before being initialized? Yeah, good question. No, I still can't do that. I don't think I can tell from that. Let's break here. Couldn't look up symbols. If there's a difference, no. Notice it proposes it, so it kind of knows it should do it. Well, let's put some numbers in there that really count. How about 1 and 8? Okay. If we can change it properly. I don't think it should have to. I think what's going on is because when you put a state in a view, the view is just a struct, so it's this kind of static entity. And I think putting the state in there, SwiftUI has some area outside that it kind of links to this view and knows that it can look things up there. And I think maybe the debugger's not smart enough to find it over there, even though it knows its state and all that. And actually, they want you to make these things private, to emphasize that if somebody's going to get past it, it's got to come in through an argument. So I don't quite know. Yeah, you would think. Well, I'm glad it's showing the bold. I mean, that part is good. I'm not. Well, we're going to do it in response to a click, so that should be okay because that's going to be handlers get running that context where they have access to the Swift stuff. So should be okay. Well, this puzzles me that it's not doing anything. I don't think it really should exactly. All right. So I guess what I've shown is if you somehow get that into selected elements, then it does the job, which at least we know it's looking in it, so that's not a problem. So I think I'll accept that as my step forward. Does it need recursive functionality? As far as displaying these elements, I don't think so. I mean, we are going to be recursive when we do the clicking and what happens there, because you're going to work your way down the children, you know, one or more. So yeah, we just need to get the numbers in, but I think I will take this. I did change it. Let me run it, but I'll take this as just my step forward. Check this in. I don't have anybody who's actively going to know until I give them a new copy of the program. So I'm going to play a little fast and loose with this. I really could turn off clustering in my release for now, but I'm going to be a little lazy. All right, so we made dendrogram elements bold when they're selected. Okay, how they get selected, it's a little weaker. All right. So I think okay. Yeah, let's find our image down here. Okay, and I'm gonna have to look up the operation switch UI. Is it on change? No, not on change. On touch or something like that. Well, they like putting in a button. Okay. No, I don't need navigation links. Tap. Well, I said put tap in, but he didn't do it. But tap sounds right. Okay. Dot tap. On tap gesture. Okay, so I know the connector. Well, let's print connector dot elements. Oops, dot ID. That's not right. Connector dot. Well, he doesn't really know it, does he? We can print the sequence number. I don't know if these IDs will be enough. All right, so if I tap a node, I should get its number, which is not going to be 1, 2, 3, 4, 5, but probably 6, 7, 8, 9, or 10. Okay, what do we get? 9. All right. 8. 7. No, 10. 7 and 6. 11. 7, 8, 9, 10, 11. Okay. Yeah. Yeah. Okay, so that's still not enough. This is where I don't think I have quite enough information here. These sequence numbers, I mean, I could light up the sequence numbers, but these numbers on the nodes, they're, well, see, these are 0, 1, 2, 3, 4, 5 got assigned as they went, although those are actually showing row numbers. But I think this was 0, 1. Well, they're probably in this order, 2, 3, 4, 5. But clicking this sequence number, I mean, I could display it and its children. That's fine. But it doesn't get me to these leaf values. And I think that's telling me I need to know my clusters to do anything with them. All right. Because all we've done in connector is, well, we have a unique ID because it's got to be identifiable. But we don't have anything, most everything else, all these things, they're about drawings. They're not about the semantic value. Could I keep the IDs of the children in the connectors? Yeah, I don't know. Well, if I did, I think if I kept their IDs, I don't know if I can get the IDs of the leaves from that. But maybe I could. Because, let's see, where's view? These are being drawn from cluster.elements. So this is coming from the cluster. But if I made sure I imagine I could get to those leaves from there. Let's see. So when I build a connector, I'm building it from a cluster, right? So find usages. Should be this one in here. Okay. Yeah. I can put, I mean, I have the clusters they come from, and this is where I build the new one. I could certainly put information in here that is the IDs, the sequence numbers of the children. Okay, so let's, I'm giving my ID and their IDs. Do I have that when I draw them, though? That would help me on the interior nodes. Okay, so I've got an element. What is element? He is an int. Okay, so if I just iterated to the, oh no, it's cluster. I've got the elements. If I get cluster elements, I definitely have the ID number first. What's cluster elements? So that should be, oh no, that's the That's the value. Cluster elements. Well, I get the sequence number. That's of the cluster. Right. So cluster.elements is the list of the leaf values. So integers in our case. 1, 2, 3, 4, 1, 2, 7, 8, 10, 11. So they do not have the cluster ID, the sequence number, because that's in the cluster. It's not in the element. Okay, so elements is the recursive buildup of its children elements. So cluster knows them, but the resulting list is too flat. No information about the cluster. But can we? I guess I'm asking, what I really want is, I want the elements of the cluster to be enumerated, but that's not what this is doing. Yeah, the ID in the connectors is the same as is the sequence number from the element. So I guess am I really after? I'm really after like the clusters. I mean, I'm trying to get the list of. Maybe do I just want the leaf elements from the cluster? I think that's kind of what I want. Now, if they were cluster nodes, leaf clusters. Yeah, I do need to select the cluster. I mean, if I were enumerating through leaf clusters, so I don't need every intermediate node, but but a cluster, there's a node for this and this and this and this, and then a node for the actual cluster. So these are dot elements, these are dot clusters. And I think I just want to get the list of element ones, but they're still clusters, so they still know their sequence number. Okay, so let's find a way to ask that. Now, I'm curious who uses cluster.elements, because I think I kind of put it in for the purpose of that drawing right there. So if it's the only thing using it, yeah, not really. Connector uses it, dendrogram view, and priority matrix. Okay. If I had cluster elements that return me just these, so it was returning self, array of self instead of the other, I think I would have the information I need to get the sequence numbers, which would give me enough information to do the bolding. Okay, so let's work on defining that. So we got cluster tests, yeah. Okay. Cluster knows its leaves. Okay, and so this kind of thing is probably a reasonable start. Okay, and if you ask for C1 dot let's call it cluster elements. Maybe leaves is maybe not bad. Okay, and then assert equal. Well, it should be actual should be E1, E2. Okay, C1 shouldn't be in there. Okay, and we don't have that function. Well, do this. Public var leaves produces array of cluster of E. We'll start empty. Okay, cluster tests should be okay by now. Cannot call value of known function. What did I call it here? Oh, yeah, that's fine. And I don't know, I can inline that without too much grief. Okay, one failure. This one, good. All right, now it's going to be almost exactly this, but different inside. Okay, so if we find element, we don't care what stuff it has. We'll put self in the list. And then if it's a cluster with C1, C2, we're going to get its elements, cluster dot leaves, and this one's leaves, and return the result. Okay, and I think that'll pass. Okay, so make cluster know its leaves. Okay, and then let's get this error warning out of there. Should include the is button accessibility trait. See if it builds. Okay. All right. Oh. So now when I build the connectors, I need the connectors to maintain this list of what are your sequence numbers at your leaves. Okay. So I think that's going to go on to connectors. Let's see, what's to do say? Activate cluster buttons. Okay, so I think what we did was we make cluster know its leaves, and then we're going to make connector know its descendant sequence numbers. And actually, I think that was a very good idea. Do you need to keep track of the children in the sequence? because I think that's going to simplify. We don't have to do the up and down thing. We just have to say the connector knows the list of stuff. That's the new list of stuff, assuming we can make that part work. All right, so this we did. Okay, cluster knows its leaves. Now we're going in connector. Connector. Okay. I guess he should be told. Is this element IDs? Is a list of sequence number? Okay. And I guess if I do that, if I add it, well, I can do it this way for now, just take a small step. That shouldn't break all the people out there that don't have it. Yeah, we've got an unused field, basically. Okay, but we need some tests for that. Okay, so what I want to know, well, maybe it's not a connector test at all, because connectors kind of, I don't think it's a great attribute of it, but it's very much a data bag. It's just a bunch of fields that other people set. And even this function, I don't think belongs here. I'd like to move that too. Maybe we'll do that in a minute. But everything in here is just being held. It's being, and maybe that's okay, because it's sort of like this is the structure of stuff that a connector node needs to know to be drawn and activated properly. And it's not doing anything about it. It's just kind of restructuring the information so that the view can handle it. But so I think, whose job is it to put those element IDs in? Well, that's somebody else's job. That is cluster, probably. No. Connectors. Right, because that's the one place that creates one in kind of production use. That's tests. That thing does it, and then this thing is passed that value. So this one should put those numbers in. All right, and so I think if our tests verified them correctly, let's go to connect. Well, they're all connector tests, which really is connectors test, because everything it calls is connectors. All right, so let's rename this one. No, I thought when I went there it was supposed to, oh, there it is. Okay. Connectors tests. I think this way I have to do it manually. Okay. But what I want to do, I've got an element cluster with no connector. I don't have anything to say. But this one, I want to say computes connectors. See cluster 3, we're saying his sequence numbers. Now, what do we call it? Element IDs. Yeah. Okay. His element IDs should be a list of numbers, and it should be the children ones, 1, 2. Okay, because he's supposed to only give us the leaves, the cluster elements from the leaves. All right. Now, if I pass him, I'm probably going to break everything else. But ID 4 should give us element IDs 1, 2, just 1 and 2. ID 5 should give us element IDs 1, 2, 3. Okay. Connector, his line length is going to get too long. Okay. Let's just make that. Because it's just holding a bunch of stuff. All right, and his element IDs. Okay, ID 4 has C2, C3, so that's 2, 3. ID 5 has C1, C4, so it's 1, 2, 3. And our last one, which is kind of resembles our full setup here. Okay, C1 has 1, 2. ID 7. C2 has 3, 4. Element 9 has 5, 6. So I'm going to break a bunch of tests till we get this to pass. Element 10 has C2, C3, which is 8 and 9. 8 has 3, 4. 9 has 5, 6. So this is 3, 4, 5, 6. And 11 must have 1, 2, 3, 4, 5, 6. Okay. All these things should fail. Maybe some more will too, because element IDs may get set. Okay, but mostly I'm expecting these. 10 failures. Okay, it looks like most of them are in this file. All right, what's the problem? Hopefully it's element IDs. Came back empty, should be 1, 2. Okay, I think we're going to find that pretty much throughout. Came back empty, should be 1, 2. Okay, let's see. So connectors, right? It doesn't have them yet, and it needs them. Okay, so that is well, center one is the connector for the first one. I think it's, well, it should be the union of connector center one and center two. They're both connectors with sequence IDs, element IDs in them. Now, I don't know what I have to do to get those set out right, but can I do center one, center two dot flat map? Oh, there's something we're supposed to do instead now. Well, this is really just $0. Give me whatever elements you have, but he should be warning me. element IDs. Oh, center one dot element IDs. Center two. Oh no, those are not the right things. C1. We want the clusters. Well, no, that's not going to be right either, is it? C1. Okay. All right. C1's. I want the connector. All right. So, well, I should be able to take. We don't need all that. If I take cluster.leaves, that gives me the list of leaf clusters. Then I want to map them to sequence number. Does that sound right? Find the connector using the cluster sequence number. Oh, that's a good question. Yeah, I mean, we should have. It really is the recursive thing, isn't it? It's not so much the leaves. I mean, we need to know the leaves for some purposes, but I think these nodes should say all the nodes, intermediate nodes. So cluster.leaves is not going to work. Leaves. Let's look at cluster. Because we'd like this list to be useful both for the tree part and the list of elements part. So asking for elements, I think we want to ask for sequence numbers. Who called this? Was that, did I only need that for this purpose? Because I don't think I need it for this purpose. Connector, element ID, leaves.map. No, that is not right. Okay. Well, okay. Cluster. Let's see. So I think that the thing I want the sequence number of this cluster and any cluster it recursively includes. Okay, so I guess I want something else. Let's say if I take that same thing, I should get 1, 2, 3. Do I care about the order? I don't think I do. this is all sequence numbers. One, two, three. Okay. And then all sequence numbers needs to be on cluster. This is set of sequence number. Okay, and let's just return set of, return that. All right, that should be a fail. Now, I'm gonna hold off those for a minute. Okay, I don't like doing this too much, really. Okay, this one failed. I guess I could comment those out, but I'm gonna leave them. And I think they're not right. Okay, because now we're saying this should be 1, 2, 3. Should include itself and all descendants. Same for this. C4 should be 1, 2, 4. C5 should be everything. Four is 2, 3, 4. And 5 is 1, 2, 3, 4, 5. This is the big messy one. 7 is 1, 2, 7. 8 is 3, 4, 8. 9 is 5, 6, 9. 10 is 1, 3, 4, 5, 6, 8, 9. 10. And this should be everybody. 6, 7, 8, 9, 10, 11. Okay, let's connect our 11. Should include C1 and C4, which has all the rest. Okay. They're still wrong. I mean, they're still not going to be right, but that's okay. This, we don't get a setback. Let's fix this. All right, so all sequence numbers. Well, that's going to be it's this recursive set again. Yeah, let's pick one that's got separate cases. If I'm going to be lazy. Got an extra brace. No. Okay. Okay, so this should be the set. Well, I think it can just be ID. Okay, so if we get to a leaf, all we can do is pull his ID. All right. And then if we get to a cluster, let's take cluster elements dot one result dot union. Whoops. Cluster dot all sequence numbers. Union with cluster 2 dot all sequence numbers, and that's the result. Um, oh, union returns a set. Okay. And then we need, yes, its own ID. Insert ID. Okay, what's your deal? All right. I don't have a good word for descendant plus all its descendants ID numbers. Okay, but I think this is what we need in connectors. All right, so if you ask for the element IDs, well, I kind of feel like that should be a set. Sorry, connectors. Okay, so we're going to take the cluster dot all sequence numbers. All right. That should be a set. Okay, going to the IDs. All right, now, hope everybody passes. We may have one we messed up. Okay, good. All right, so connectors now know the list of all sequence numbers of a cluster and its descendants. Yay is right. Okay, I think this is going to be very helpful. All right, so I left a couple of threads. One is I don't think anybody's using leaves anymore that I worked so hard to put in. Usages should only be in tests. Oh, leaves. Okay, that's only in tests. Okay, so I think we can take this out. And then in its tests, okay. So a little stumbling around there, but I think we're getting there now. Okay, so so that was kind of one of these two-level things. You know, we put requirements on this thing that needed all sequence numbers to do its job in the end, and then we had to define all sequence numbers. I don't like stacking things. You've seen how much just keeping track of one variable name from one file to the next is sometimes an issue. So stacking is not a great strategy for me. What I'll do instead, usually I'll comment out the one that's failing that I don't really expect to be involved in this new helper function. All right, the other thing I said I wanted to do was take connector center and make that be clusters or connectors problem. All right, so whoever's calling it is going to have to do some work, and that's going to be here. Connectors dot center. And again, I think that makes sense because we are making this connector. Well, so oops, connectors. That really should be complaining more strongly. Okay. Make connectors on center rather than connector. And again, it's really not, it's not a function that's really doing anything about connectors or connector. It's kind of, it's dependent, where'd it go? It's dependent on the row number and it's dependent on the cluster, but it's not dependent on anything really about connectors, other than connectors is the one that wants this specialized information. So we'll give it to it. Okay. I think we may be ready to go back here. All right. So we have selected elements. Let's go see that thing. Let's make that a set, so it's compatible with what's in connectors. And I think that's okay. All right, now our function, right here, our tap, we've got connector because we're in clusters, so we can form this closure that takes connector. And I think we just want to say selected elements equals connector dot element IDs. Okay. Now we think that should make this right because it's looking at selected elements to decide which ones are selected. All right, let's see how that goes. Well, I ran my test again. Okay, I'm glad they pass. So I'm expecting the initial view to be wrong, but when we click things, the leaves should light up properly. So these two, oh, interesting. Nothing. Fine, fine. Partly fine. Huh. Okay, there's a pattern and a half. Yeah. Let's look at, let's set a breakpoint in our tap method. I want it right here. So something's going on. Okay, so this should do something. Okay, so let's print connector. Yeah, maybe I should print connector.element IDs 5, 6, and 9. Oh boy, do I hate this. Can I print self.selected? No. Hmm. Three, 4, 5, 6, 8, 9, 10. So we left out 1 and 2, and we left out 11. Okay, that seems like a good set. 1, 2, 7, and 11. I mean, these look like they're right to me. Why they would... We mark this as state. Oh, am I getting the IDs wrong? That's a question. That is a good question. Yeah, that's what's going on. We're fooling with integer sequence numbers and integer elements, and the texts only have the elements. So it's the element IDs that light up. Okay, that makes sense in its own cruel way. So we said node 10, which may be over here, because this is 1, 2, 3, 4, 5, 6. So when we click here, it's, well, this is 1, 2, 7. Let's see what happens if I click there. Let's take out that breakpoint. And continue. Okay, we know this is 1, 2, 7, so we expect the first 3 to light up. Yeah. Okay. Alrighty. Okay, I think let's take a break first. I think we know what we'll have to do because these things now, these elements are only, they're only showing the element. They don't know the ID. And so we need to get back up a level to the cluster things that know the IDs, and we'll get that. All right. So 3 or 4 minutes, and we'll come back and get the bold stuff working right. See you in a few minutes. All right, welcome back. I have a feeling this cluster.elements, all right, the enumerated we don't need anymore because we're not doing anything with number except displaying it in the text field just so we knew which row number we had. And that row number does not bear anything to the sequence numbers or any of that stuff. So it was just kind of an information thing. I think what we want here is cluster.leaves that we just added and deleted, and now we're going to add again. The leaves are the cluster, the dot element versions of cluster. And so that was the ones coming in here. Okay. Let's back up and see if we can pull that in. I don't know. I didn't get anything here either. No. Something is really weird. Okay, if I... Okay, we changed those. Okay. Make tab mark selected items. All right, and this. How do I have nothing in the last 24 hours? It seems like it's frozen. But yet when I say commit, it goes. Okay, I'm gonna have to go. Branches, recent location. Is it getting there? It's not, apparently. You know, there was some blip about GitHub changing something, and I just checked that I could still push things to it, but maybe I'm not getting it. All right. We should be writing this in our sleep by now. I don't know if I can undo in this file. Cluster knows its leaves. Okay, our test was still there. Good. Is that the case in here too? It is. All right. Let's make sure leaves still works. Okay. All right. And now, so let's take the enumerated off first, get that straightened out. It's just element in element. Okay. And that, oh, I do use number. Okay. Okay, so cluster.elements returns an array of the leaf elements from the element. Cluster.leaves returns the actual element, dot element thing that knows, like any good element knows the sequence number and the value. So that's the one we need for here because we want to work with sequence numbers. So cluster.leaves, and then this is, I guess, a leaf. So now this is leaf dot value, leaf dot well, I can ask it elements, but that seems like the hard way to do it. But let's do it. Leaf dot elements of 0 is the element, is the value, and then selected elements contains leaf dot. I really don't like that. There it goes. Okay, sequence number. And position uses the number. We don't have a way around that. Okay. So it's going to give us hopefully the element and this at number. Again, it certainly doesn't need to be in our view. Oops. Okay, if that builds, I'm guessing it'll run. Okay, that went away. Good. All right, cluster and select. Hey, that's not. Oh, we put 8. 1, 2, 3, 4, 5, 6, 7, 8. One of these nodes is there. But if I click on this, I should get the 2, 2, 2, 2, 4, and everything. Okay. Makes me really happy. Okay, so now we have tab selects and bolds the proper elements. Okay. And now this is where the genius of Mudge-Shark's suggestion over here, keep the ids of the children and the node itself. Okay, so the sequence numbers that we have in the dendrogram view are also the ones we want for the image. And the system name, this one is well, it's if selected elements dot contains it's this one's ID. If it's that, it's, yeah, diamond dot inset dot filled. Was that the name? Otherwise, it's just diamond. We'll check those in a second. Beta. Diamond and diamond.inset.filled. Okay, good. All right, let's run this. Okay, so 1 and 8 are selected initially. That's why that's doing it. Oh, yeah. I love it. Okay. Oh, boy, this is great. Other than that initialization thing, like, boy, can't we get that right? Very good. All right, so now selected nodes. Show filled diamond. Good. How are we doing here? Highlight selected elements bold. Yes, we did that. Activate cluster button select nodes. We did that. All right. Make the selected nodes pass through filter. No, we haven't done that, but we need to do something about set up initial node selection. Now, what I don't know is this. I guess if you came in and saw this, would you think, oh, I can click on these diamonds? Okay. Whereas I think if you came in and saw this, you'd go like, hey, some of these diamonds are filled and some aren't. And now the other, I don't know if it's worth. Well, the other thing that crosses my mind is if these diamonds were the descendants of a given node were gray or something like that, would that give you the clue? I mean, it'd be really nice. Oh, if like the lines were green or gray, depending on their connector selection, that'd be kind of cool. That feels very doable. If you're selected, make your lines green. If you're not, make them some sort of gray. But I don't know. I feel like this feels more clickable than this. I think as soon as you figured it out, you'd know it. But yeah, the other thing I was saying was color. If the topmost selected node was fully green, and these were like a lighter shade of green or a gray or something to make it differentiate selected or not. But I don't think that would help you with coming in. If this was green and this was gray, would you go like, oh, I got to click the gray one? I don't know. I guess that's, even if I only have one true user, I guess I could do some user testing and just not say anything and start like this and see what happens. But I think, okay, if we could get this initialization right, that would help I would even take nothing highlighted to start with. Would still be a step forward. But like, what would make you click on a green if nothing was highlighted? All right. Let's start there because that's at least semantically reasonable. Okay. Nothing's highlighted. You got to click something to get it. Now, what might be the case? But boy, maybe I just have to research this. But something is just weird to me that I can't set that value in my constructor. But I guess I don't have. It is my only state, so it's allowed to be different. Okay, let's ask. Swift UI initialize state in constructor. There's some way to get to the, yeah, that's it, the underscore thing. That's probably what we need to do. Equals cluster dot all sequence numbers. Okay. Oh. State. Oh, I'd say state. Okay. Okay. I'm going to change that when I get an opportunity. All right. Now, I want, okay. I want to take cluster dot leaves. So, whoops. This. Am I doing that right? No. That one. Okay, so if cluster.leaves has a first node, cluster of int, okay, unfortunately I'm doing some type stuff, but I want it like that. So if cluster.leaves has a first, no. Cluster. I'm getting the wrong thing, aren't I? Cluster.leaves. His type is cluster event. Well, that's not what I want. Elements. Oh, that's the cluster. I'm trying to get that first node selected. The cluster is there. So I didn't want the first leaf. I want the first cluster. Well, maybe I should find a way to express that directly. And the connectors are there. Yeah. Yeah, so I mean, that's true because of the way we built our sequence numbers. We always numbered all the leaves first, and then the first cluster is that plus one. Maybe we're willing to let that be. Okay, so let's say I want its parent. Okay, so that is cluster dot leaves dot count. Zero through n, I think, right? So the leaves 0, 1. Or am I missing that? Let's find sequence number. Sorry. M map. Let's take the matrix. Yeah. First. Well, I think Yeah, the connector has the list. And the connectors, well, is that formed? When do we build the connectors? They're built here. Well, I think what you're saying is right. I just can't remember if it starts at 0 or 1. Let's go back to that algorithm page. Start m equals 0. Increment and merge. L0, sequence number m equals 0. Clusterings are assigned 0, 1. Okay, so it is 0. Maybe that's okay. 0, 1 leaves dot count. Let's try that. Nope. Why is this 7? I think what we saw them being 1 and 2. So let's try +1. I'm not 100% sure. Let's see this again. E1, this should be 7. 1, 2, 3, 4, 5, 6 should be cluster.leaves.count. Okay, let's break. Okay, it is one based. Okay. Cluster.leaves.count is 6. Oh, let's assign this to the actual state value instead of floundering around. We don't have a list of connectors yet. So this is a set, and we can do it that way. So the list of connectors is built up in the view, whether that's necessarily the right one or not. Okay. I'm happy enough. I think it's a little arbitrary, but I guess, yeah. Okay, so set up initial selected values. So the topmost cluster, which is also always the best cluster of 2, is initially selected. Okay. Now, this will blow up. Is that true? Fix them how? I think they're all right. Or unless you're saying the actual drawing code, we got some garbage going on. but I think each diamond selects all and only its children. And I'm not too worried. This list might be, 40 or 100, but it's not going to be 100,000. Okay, so let's go through kind of the functional aspects. So the worry I have here is if cluster.leaves.count, let's say there's only one node coming in, or yeah, if there's only one node coming in or zero, we probably need we kind of bounced around. We started off with that 1/8 that was kind of arbitrary, so arbitrary stuff got selected. But then we switched briefly to empty, and then we switched to everything selected, and then we switched to trying to select just this. All right. I guess the thing I want to worry about is this count. If the count is less than 2, then I don't want to do this. I want to be empty. Okay, so I don't know if well, maybe I should just do it at the top here. If let leaf count equal all right. That should work the same. It's good enough for here. All right. I think I'll be calling that done. Okay, we've got the lines. I guess the other thing I was thinking was, what if your lines knew this characteristic? Let's do this. Let is selected equals this. Okay. Then that background, but the lines. I wonder where it gets its color. Yeah, that's yeah, changing the line width might be the way to go, because then it sort of goes with the bold stuff as well. But I'm puzzled where it got its color. So background, I must have it set up on here somewhere. Foreground color, okay. Right, and then the line, well, we can try this. It'll just be an experiment. One line should be bold. Top line, yeah, in each one. Okay. Yeah, I just hard coded it. It's not. All right, so now I think I can put this on here. Is selected is 3, else 2, just to get the, oh, I guess I don't need the dots here. What if I group those? Okay, I'm resisting putting selected on my passing selected in, but maybe I shouldn't. I can do it on each one. See it work, and then we'll decide. So everybody's bold. Let's take it off here. Okay. That's more what I have in mind. Those corners could be a little sharper, couldn't they? Notice if I click twice, it doesn't change it, which is a little unfortunate, but I'm not sure what change would be. Maybe slide it up to apparent, but I don't want to fight it that hard. All right, I think that's acceptable to me. The lines are only for the purposes of these things, so that's... Or I could put them outside. I could put them in horizontal line. Oh no, I don't know if it's connected or not. Selected or not. I mean, from that perspective, this level is the one that knows what selected means. All right, let's see one more time. Okay. All right. And I really do think, I think that that contrast to me really suggests that clicking one of these other things would make their lines bold too. Whereas just the diamond, I think suggested it a little, but not all the way. So I'm happy there, at least for now. All right, let's see. To do. Set up initial node selection. Now the thing, pass through the filter. I don't want to do that until I have tunes. So I think I'm going to work back on the graphics of it a little bit and see if we can make it work horizontally. And along the way, I think we can simplify the way it draws a little bit. I wanted to just draw from the right axis and go from there. All right, so well, let's start here. So the Z stack, it's drawing this text, the frame width times 1 minus the percent, alignment leading. Remember, we had this goofiness before. Width is twice the frame width minus the percent, alignment trailing. Ah, boy. What I'd like to do is make, well, what's diagram percent? Is it 25% still? 75. Yeah, I was debating about that. If right aligned would be the right thing. In a way, I think the worry is more commonly like how much space we give it. The titles can be really long on the data we have, and short titles are never all that short. But all right. So, but yeah, we'll definitely have to make sure we make that look right. The other one that crossed my mind was like in a table of contents. Sometimes they put dot 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 dot, at the end, and connect it to the page number or whatever. All right, so this frame width 1 minus the percent, that's okay. X frame width times diagram percent. Like somehow that should be 1 minus diagram percent. X is frame width. Well, really, it should be 0. All right. So if this is on the far left, let's try it at 0 and see how this looks. It should overlap. Yeah, we can definitely clip. All right. So I'm expecting an overlap with the right stuff on the left, or the correct stuff on the left. Okay. Now, I don't know if I can. Can I flip it? I can do a scale effect, scale. What if I do -1? I don't know if that's the right way to even do this or if this will work this way. Yeah, we're going to have to offset it too. I'm kind of trying to flip it first. Ooh, okay. The flipping kind of worked. Oh no, I flipped it vertically. Right. X minus 1, Y plus 1. But yeah, we need to offset. And we are offset. We're too much offset. Well, maybe that's the price. Maybe we're not too much offset. The price of using all these little short numbers, this is where your suggestion to write a line might be better, which we can probably try and see how we like. Alignment leading, alignment trailing. What's this one? So the frame width is 1 minus diagram percent. So, which I think is okay. That's the 0.25. So his frame is 0.25 times the full width. And then we stuck him in there with twice his width and alignment trailing. Okay. These do work. Okay, so let's make this trailing. Well, that's too much. Yeah, I mean, it looks like maybe the dendrogram does need a little more offset, but I don't know. I don't have a ruler. Do I? I do. Okay, so my screen is 10 3/4, the sandy colored stuff. And the right side of these numbers is on 3. Put a border on the frames. Yes, good idea. I left off one, didn't I? Okay, so I don't know what the blue means there. Because we just saw, even without the red, we just saw the bit of blue. The red being offset down seems okay because we want line 0 to be the center of the action there. But I guess we left space on the right. Yeah, let's take off that space on the right of this. Frame width 1 minus level. Now, isn't that kind of weird? This should still be 75%, like, why is he not 75%? He's got a padding of some sort, but no, I took the cheap way out of scaling it by -1, so it flipped, but I'm going to kind of regret it, I think. I would have thought his frame width. I don't think there's enough padding to make a difference, because that somewhere had padding 4 or something like that. And I could believe that's maybe kind of like that. It looks a little more on this side, doesn't it? But I find it very odd that the diamond is outside the frame. All right, so frame width X. Did we do anything with frame width other than conceptually? Maybe that's the problem. His frame. Also, I'm still puzzled by this double frame thing we did. I guess we looked it up and found somebody suggesting it, but we're saying the frame width is 25% with trailing alignment. And then on top of that, the frame width is 50. 2 times frame width. Yeah, frame width is twice the width. I don't know, it's like like somehow we're not. Well, I wonder if we need this on this side, I guess. If this is leading. Let's see. Oh, I got my borders mixed up. Okay. I mean, I'm off screen. There's no doubt about that. Frame width. So the space I want to draw the frame in, maybe this padding should be after. The frame width is 25% with leading alignment. I feel like that should be exactly on the edge of our drawing with a little bit of border in front. And it most definitely is not. Now, what if we took this one? That's what we did down there. Now, that does look like a quarter to me. Well, 1, 2, 3 and a half. Okay. It's still centered. Yes, that's really the problem. Okay. So before we did this. Then we did this. Position X is 0 on that frame. That's the part I don't get. Check text alignment to trailing here. I think that brings us back to where we were with the numbers on the far right of their box. Right, but like there's the blue box. Like let's move this over. Oh, with only one frame. So do you want by itself like that? I mean, there's the blue. It just looks like it's off, way off. And there's no padding. I would feel a lot better. I mean, I said X4. Why isn't that box? The width is wrong, right? That's the problem. Frame width. Yeah, I almost. I don't. I think. Well, this to me. I mean, this still looks like it. Let's do dot centered on this. Dot in their center. Yeah. Okay. I feel like we're going to get our number right on the edge of the frame. And why? Yeah. To me, it looks like the box should be shifted over like half the distance. But I don't get why that should be that way. I mean, I think that's more the way this should go. And then a choice whether we're positioning leading, trailing, whatever. I mean, this box should be padded. We haven't put this other one in a box is part of the problem. It's basically it's taking the whole screen. Okay, I'm going to try that. All right, I think this is slightly improved. Oh, it's so weird. I mean, looks wise, I think this is improved in the sense that if we make this leading, it should look like we want it to look on the leading side. And I think it's got an invisible 4 around it. Right. And if we put trailing, it does overlap this, but I think that's the fault of other stuff. All right. Now, let's add one more blue border. Well, no, colors are cheap, right? Gray. I want to make sure the padding is there. I don't see it. Is it drawing in? No, I guess that doesn't do anything. Okay. But I think at least with this approach, for whatever reason, it's positioned outside the edge of the outer frame. I don't think we're doing anything. We're just saying width and height. Padding 24. It ought to be. Well, maybe that's this 24. I can believe that. All right. Let's take the blue box off. I think we will leave this trailing for now. Maybe the box doesn't hurt anything. All right. Positioned like that. Okay. Now this one, I want to say its frame should be frame width times diagram percent. Okay, I'm trying to shrink it. And it does not have. Oh, these are a Z stack. That is probably part of the problem. Let's do this. So they come in a row. Okay. I may have affected the other box too with the H stack. Uh-oh. Can we still stop it? Yeah. Apparently that's a bad idea. Okay, I don't know why. Okay, so, well, that does tell me that there's something going on when I do that. Maybe this position is incompatible with it. I don't think that should be a problem. It's a bunch of stuff and another bunch of stuff. Oh, well, that's not going to work. Huh. Oh, that's on the text. So that is not a problem. Because we definitely need Y to be scaled by the number. What would be doing this for each? what if this should be a V stack? And these should be, well, I don't know. Oh, nuts. Okay, at least I am not so frozen there. All right, why? So I think this frame width has nothing to do with the individual text items per se. Okay, so I can say the width of the overall thing should be that. And bold font color, let's put the border on the outside. Okay. Oh, this is still should be a V stack somewhere as well. And it needs frame, so why is it even running? Okay. My goodness. Well, these are messed up. These are way apart. All right. Width, placement wise, though, how are they? I think they're kind of okay. Let's move them to leading. I don't think I need this padding here. Position. Let's do leading. Make sure that box is still placed where it should be. Okay, well, he's off the edge now. Wait a minute. That looks centered. So yeah, I'm trying to split it into the left view and the right view. So the left view is this stack of these, and the right view is the stack of connectors. Now, something is scaling is going funny vertically. I don't know why. It may be that maybe the V stack is doing its own thing. Now, this Y scale. Let's make sure what Y scale is. I'm not sure if I should be moving back. Font size times line spacing. 24 times 2. I guess my first thing is, why are these things so far apart vertically? That is not 2 lines worth of space. Now, That's those, and the parent is off the screen. But the boxes are horizontally, you know, in their element here. All right. Let's make this minus 0.75. Trying to get his box back in bounds. Okay. That's working X-wise. All right. Well, clearly something's going on, so maybe it does matter, but the 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 Z stack was sort of letting me position. That was how we were getting overlap sometimes, because they could be positioned independently. What I'd like to do is something like this is doing, although the boxes don't convince me of that. I'd like to make it so this is 25% of the screen and this is 75%, and everything is horizontally contained in its own box. Now VStack, oh, I know what's going on. Okay. Yeah, maybe you're right. Maybe the Z-stack is the problem. The V-stack says I'm going to spread these elements out in whatever way I want vertically, and I don't want that. So maybe this does have to be a Z-stack. Let's do that on both, because yeah, the V-stack is probably trying to take over the positioning. I think you're right. So now I'm trying to let the H-stack do the positioning horizontally. Yes. Okay. And the V-stack vertically. Z-stack, we do it vertically in there. Okay. Now, let's take that 75 out again. Oh, it's down here somewhere. But I think we're positioning by distance too much. Yeah, something's got to multiply. See, this box should be contained, and it's not. All right. Where is he being defined? Frame width times diagram percent. Let's divide. I'm just trying to get things kind of back in scope and range. All right, but I see the clock is not with me today. Okay. Interesting. This, I did this at the wrong level or something. I guess I made him small enough. Well, no, his red box. See, people are drawing outside their box, and I think that's the Z-stack allowing that to happen. All right, I'm going to take this out, get us back to something semi-plausible, and call it a day. All right, so I think if we were to, you can just barely see this, but if we were to shift this in a little bit, it would be sort of okay. All right, again, I don't like this blue box that seems to think it owns the world. But I do think the horizontal stack, to let that control the fact that they need to stack up against each other, that feels okay. And it's willing to give them more space if they need it, but I don't want them to need it. I think this line's probably going just, maybe even a quarter inch or an eighth of an inch outside there. This one I don't trust. I don't know. You would think the padding on the H stack would do it, but anyway, it's after 3:30. We'll stop here. I think we're closing in. It was a pretty painful day or two there to get this right in the first place. I think we'll close it in and somewhere we still have too much or not enough border on the left. Well, it's on the right as far as this is concerned, but it ends up on the left. Too much border, and we'll have to address that. And then I think I want to take out this -1 stuff and get the thing properly flipped. Okay, so it draws it, assuming the lines start at 0 and stuff like that. So that may change the connector even. We'll see. All right. Well, thanks for joining. Thanks for all your suggestions again. And next time is tomorrow, Wednesday, 2 to 4:30 p.m. Eastern Time and 6 to 8:30 p.m. UTC. We're closing in. I'm happy with the progress. Thanks for joining. Bye-bye.